All right, let's talk about a different special kind of factoring. This is for a special case called difference of squares. You can do this when you have a problem where you have a square, some term that is squared, minus another term that is squared. That's why it's called difference of squares. You have two squares, and they are being subtracted. For example, x squared minus 25. X squared is just x times x. That means it's x squared, right? 25 is 5 times 5. That means 25 is 5 squared. So what we have here is x squared minus 5 squared. Let's jump in how to factor this special kind of problem. So let's talk about how to actually factor this stuff. Let's start with understanding by breaking these up into how we get there. How do we get to x squared? Well, we get to x squared by x times x. How do we get to 25? Well, we get to 25 from 5 times 5. All right, so these are the square roots. X is a square root of x squared. 5 is a square root of 25. What we do now in our difference of squares, we write our parentheses. Then we take the square roots of our first term and we write it twice. We then write a plus and we write a minus. And then we write the square root of our second term. So all it is it's just if you have a squared, the formula goes like this. A squared minus b squared, right? You have something squared minus something squared. You just make your sets of parentheses. You do just a, which in this case was x, plus b, which in this case b was 5, because b squared, 5 squared is 25, right? And then we have to do it again, but with a minus in the middle instead. Now, just so that you can see that this works, if I FOIL it, x times x, that's going to give me x squared. 5 times x, that's going to give me plus 5x. X times negative 5, that's going to give me minus 5x. And then 5 times negative 5, that's going to give me minus 25. And of course, the plus 5x minus 5x cancels, and we are left with x squared minus 25. X squared minus 25. Let's do it again with this one. All right, so x squared, what's the square root of x squared? Well, that's just going to be x, because x times x is x squared. What about 49? Two of the same number multiplied together give you 49. And if you don't know it off the top of your head, you can check it in your calculator. Do square root of 49. What you wind up getting is 7. So 7 times 7 is 49. And we're just going to set it up the way we did last time. Two sets of parentheses, x, x, plus 7, minus 7. And that's it. All right. So this first one here is an example of something that you cannot factor. This is something that you need to remember. You cannot factor a sum of squares. A sum of squares. As long as it's already, like there's already no GCF in it, and there's no GCF between x squared and 25. As long as there's no GCF there, you cannot factor a sum of squares. All right? Now here's a trick. They may try to trick you and show you a sum of squares like the second one down here. By the way, real quick, going back to the first one, we call that prime when we cannot factor it. It's prime. But let's go back to the 4x squared plus 16. 4x squared plus 16. So you can't factor it with the difference of squares method because it's a sum. It's not a difference. There's a plus there. However, there is a catch here. The catch is that, is there anything in common? Is there a GCF? The answer is yes. 4 and 16 have a 4 in common, which means we can pull a 4 out, and we're left with x squared here because 4 divided by 4 is just 1, so there's just a 1 in front of the x squared, plus 16 divided by 4 is 4. So we cannot factor it with a difference of squares method, but we can factor it by taking out the GCF. So I do want you to be careful. If in your homework or tests or something you see a sum of squares, it is prime if there's not a GCF. that you can take out of it. But if there is a GCF that you can take out of it, be very careful because they can be tricky with those sometimes. Alrighty, let's try some that are a little bit more difficult because the a is no longer just x squared. The a is now a squared number with an x squared. So just like how we took the square root of x squared, we now have to take the square root of 49x squared. And we can split that up into two things. 49 times square root x squared. What's the square root of 49? We should remember that from earlier, 7. And then the square root of x squared, x. So we put it back together and we get that 49x squared is 7x times 7x. What about 16? Well, 16 is just 4 times 4. All right, so now we open up our two parentheses again. We put in our a, or at least the square root of our a, I should say. We put a plus, we put a minus, and we put the square root of our b. And that gives us the answer for the first part. Getting the hang of it now, right? Now this next one, there's actually two ways to do it. We could do it the way that I just did it. We could say, okay, well the square root of 4x squared is just 2x. 2x times 2x. And then the square root of 36 is just 6 times 6. So we could set up our two parentheses here as 2x plus 6, 2x minus 6. And that is one answer that is correct. But there's actually another answer that's correct that I think we should get used to doing more often instead. And the thing that I want you to get used to doing as we learn more about factoring, what we're going to find is it's usually good to start your factoring problems by taking out the GCF if there is one. And in this case, there is a GCF. Let's take a look at 4x squared, and let's take a look at 36. So factors of 4x squared, I'm going to ignore the x squared for now, and I'm just going to look at the numbers, okay? We have 1 and 4. We have 2 and 2. Let's take a look at 36. We have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. And we have 6 and 6. What's the greatest common factor? Well, that's just the greatest number that these two lists have in common. That would be a 4. We see it in both lists. So instead of going straight to our difference of squares, why don't we take a 4 out? And we're left with x squared minus 9. Of course, x squared minus 9 can still be factored further because it is a difference of squares. 9 is a square, x squared is a square. Square root of x squared is x, and we do plus 3x minus 3. The 3 coming from the fact that 3 is the square root of 9. This is a good answer. What I had earlier is a good answer. They are both correct. All right, thank you so much for watching. If you found this video to be helpful, please leave a like below, and we're going to have more content coming out soon. Thank you so much.